This video, we are going to discuss about the problem minimum characters to be added at front to make a string palindrome. So we are given with a string str of length n, and we have to basically find the minimum characters which can be added to the front of this string to make it a palindrome string. The point to consider is that we can only add that character in the front of the string. We cannot add that character anywhere else. So let's say that the string given to us is ABC. We can see for this string, the answer is 2 because if we add CB in the front, we will get a palindrome string. Before moving on, let's also discuss that how a palindrome string is, what is a palindrome string, and how we can basically add character to make a non-palindrome string to a palindrome string. This is what we have to discuss in this given problem. If we talk about palindrome strings are those that if we read this string if we reverse a palindrome string, so this reverse palindrome string is always equal to the original string. This is what a palindrome string is. Let's say the string is madam. This is a string. If we will reverse this string, let's say R, it will all again become madam only. And you can see that the original string and the reverse string are equal. That means this is a palindrome string. Now we have to find a minimum number of characters which can be added in the front of the given string to make it a palindrome string. Let's say the string given to us is ABC. You can see one thing that if we add in the front of this ABC, it will become a palindrome. This is a final palindrome string. So the answer for this ABC will be 2 because we are adding minimum 2 characters to make it a palindrome. You can see that you cannot prove that less than 2 characters can make it a palindrome. At least 2 characters will be needed to make this string a palindrome string. Now, if we talk about that, how we can solve this problem. To solve this particular problem, the brute force approach will be, it will take time complexity of O of n square. The brute force approach will be that we will first add a single character and then we will traverse to the string. Then we will add the other character. So it will take basically a time complexity of O of n square. But if you will just check out the time complexity expected, which is O of n, that means we have to solve this problem with a time complexity of O of n. So this type of problem can be solved using KMP algorithm. The KMP algorithm is a very famous algorithm for solving string problems. And if I talk more precisely, a concept of longest prefix suffix array, which we also call LPS array, the concept of LPS array is used. So in this problem, we'll use the concept of LPS array to solve this particular problem. Now, before moving on, we will discuss in detail that what is a LPS array. We'll understand how this LPS array works and how we can construct the LPS array. After understanding that thing, we will understand how we can implement the concept of LPS array in this problem to solve this particular problem. So now we will discuss that what is a LCS array. Let's say that we are given with a string and we have to find the longest prefix, or we can say the longest perfect prefix, which is also a suffix. This is what we have to find. And we have to find the length of it. So first of all, if we talk about the perfect prefix, so if we take a string ABC, so its prefixes are first the empty string, it is also a prefix, then A, then AB. But ABC is not a perfect prefix because it is just testing only. So this is not a perfect prefix. But empty string A, AB, they all are the perfect prefix of this particular string. And if we talk about the suffix, so for ABC, its suffix is first C, then BC, then ABC, and empty string is also a particular suffix of ABC. So here we can take the complete string as a suffix, but because we are talking about suffix, not perfect suffix. But we are talking about perfect prefix, so we cannot take the complete string. Now what we will do, we create a LCS array out of the string given to us. And this is particular is a part of KMP algorithm, which is a very famous algorithm for strings, which is KMP algorithm. Now what we'll do, first we will consider this particular substring and we will find the length for such prefix, which is also a suffix. So for this string A, you can see its prefix is just empty string and its suffix are 2, empty string and the A. So the a prefix which is also a suffix is just temporary string, so it is 0. The length of it is 0. Similarly for AB also, the length will be 0. For ABC also, the length will be 0. For ABCB also, the length will be 0. So this will be 1. But if we take this particular string, you can see for ABCBA, there is a prefix which is this A, and there is also a suffix which is just this last A, and this first A is the prefix. You can see that they both are equal. So we have got a prefix in this particular string which is also a suffix, and whose length is 1. So for the LCS array, its length will be 1. Now let's take this particular string. For this particular string, you can see that we are having a prefix AB and a suffix also AB. This is a prefix AB, this is a suffix AB. So for this, the answer will be 2 because the length of AB is 2. Similarly, if we also add a C here, it is increased and now the string is 3. But if we again add one more A, means now this is a complete string which is A, B, C, B, A, B, C, A. Now you can see that there is only a which is also a prefix and also a suffix. We will just take it. So this is how this LCS array is constructed. Now we will see the algorithm behind how this LCS array is constructed. This is the algorithm which we basically use for finding the longest prefix suffix. What we will do, first of all, we will take our LPS array and we will initialize the zeroth index of it as 0. So while understanding this particular algorithm, let's also dive in this so that it will be more clear to you. So let's say that we have not created this particular array. Let's just make it empty and we will dive in this thing for you. So let's say this is a string given to us, and currently we are creating this LCS array and its zeroth element is just 0 because for a single character, it's always there is no prefix present, no perfect prefix present because we are talking about perfect prefix. So what we will do now that as it is given here, in this particular case, initially the length will be 0 and we will take a iterator I which will start from the second index. You can see that here will be our I and currently our length is 0. There will be two cases. If the current character is equal to the character at the length where our length is, then we can increase the length and we can make it equal to the current LPS value and we will also increase the value of iterator. But here you can see that this is not the case, means our current character is B and our length is currently 0, means currently pointing towards A. This is our length. So it is not equal to A. In that case, we will go to the else part. Here also there are two techniques that if our length is not equal to 0, in that case we will make our length equal to the previous length. Otherwise, we will make our length equal to 0 and we will make I plus plus. So this will also not the case because our length is 0. So we will just make this particular case which is length equal to 0 and I plus plus. So here what we will do that we will make our length equal to 0 means for this first index also our LPS or not length, our LPS equal to 0. So the LPS array is this LPS, sorry, not LCS, it will be also 0. Okay, like this. And then what we will basically do here, we will make our I the next index. Now for this case also you can see that A is not equal to C. This case will also not run and again we will have 0 here. Similarly for the next case, when our I will be at the next position, which is at B, for B also it is not equal, so we will make it 0. Now let's move towards the next index which is A. Now you can see this A is equal to A, means our current index I is equal to length. So this particular condition will run. That will increase our length. So now our length is 1 basically. We will also increment the pointer of length to here. And we will assign this value to the current LPS. So this for this particular A, its answer will be 1. Then we will increment the value of I. So now I will move towards the next index. And you can see here for this particular, you can see that there is a prefix. That prefix, this length is indicating the length of the prefix, which is just A from 0 to this length. And here, this is the A which we have considered. This is the common prefix and suffix for that particular subarray. Now we are considering this B, and now also you can see that the length it is pointing towards B and I is also pointing towards B. So again, this particular condition is true. So it will increase the value of length and the LPS will be equal to length. So now length will be 2. It will update the length pointer and this will also be 2. And the ith pointer will also be updated. Here also you can see again the same case has been happened that this C is equal to C. So again the length will be increased. The current LPS will be 3 which is equal to length and again the value of length and this I will be increased. Length will be here and I will be here. Now you can see this length is not equal to I. Means this character B is not equal to character A. Means the length, the character as I is not equal to character at length. So what we will do, we will move to the else part. Here also there are two conditions. For the first condition, if length is not equal to 0, then what we will do? And again, the same case is here because the length is not equal to 0. As the given length is not equal to 0, as the given length is not equal to 0, in that case, we will first do this thing. We will make our length equal to our LPS of length minus 1. So our length will become equal to LPS of length minus 1. So now you can see what will happen, that our length will become equal to LPS of length minus 1. So the previous length was basically 3 and LPS of length minus 1 is basically this particular 0. So now our length will become 0. That is because we are moving one step behind it and we will do till we will get a particular character which is equal to this A. Till then, we will just make our length one step behind. So our length will basically go at the last here until this particular position will go on. And so just so because the value of LPS length minus 1 was 0, so now our length is at 0th index. Now you can see then you can see the value of I is not changing. We are just changing the value of length. Now in the next case, now you can see that the character at length and character at I is equal. Again, this condition will run. Length will be increased and the LPS of I will become equal to length. So length will be increased. It will be now 1 and LPS of I will be equal to length, which is 1. This is how we will find the LPS array. So we have understood the algorithm which is given and the particular process how we can find this LPS array. Now we will discuss how we can use this LPS array to solve our particular problem. So now we will discuss how we can implement the prefix suffix array method in this particular problem to find that whether this particular string can be made to a palindrome with the minimum number of characters. Means what will be the minimum number of characters which are required to make this particular string a palindrome. So let's take an example of a particular string, let's say ABC only. What we will do, the first step is just what it is similar to what we do in pattern searching. Okay, we will take the original string. Let's say the original string is S, which is ABC. We will take a reverse of this original string. Let's say CBA, and then these string and this reverse string will be concatenated. So it will be ABC, and but with a special symbol between them. Let's take a dollar sign and then CBA. So now what we have done, we have basically concatenated this particular string, which is a basically addition of S plus dollar sign plus the reverse string. Now what we will do, we will apply the LPS technique for this particular string. We will find its corresponding LPS array. Let's find it. So the corresponding LPS array will be, for first it is always 0 as I told you. For second AB, for AB also you can see there are no common prefix and suffix. It will be 0. Similarly for ABC also it will be 0. For this it will be 0. Here also it will be 0 only. EB also it will be 0. But for A, you can see for this particular string, which is the complete string, we have a common A, which is also a prefix, which is also a suffix. So we will have one. Now what we have, basically, the answer is, in this case will be the size of the S, which is 3, minus the LPS value of the complete string, which is present at the last index, which is 2. And you can see for the string CBA, 2 characters are needed to make it a palindrome. So this 2 is the answer. Maybe you are thinking how it is possible. Let's take one more example to understand this particular problem. And this is what is based on the KPM algorithm, the concept of LPS array and pattern matching. I will recommend you guys to also have a look on the pattern searching in strings using KMP and different algorithms so that you can get a more clear idea of this particular approach. I have told you complete that how we can find the LPS array. That is what I have told you in this video only. Now let's take another string. Let's say that our given string, the string given to us is, let's take it A, B, C, D, and let's say B. For this particular string, you can see the required number of characters are just 2 because we have to just add a CB, CD in the start. Also, not CD, it will be DC in the start, and then we will get a palindrome. But let's find this using the technique which we have discussed. First, what we will do, we will find the reverse of this string. So it will be DCB, AAB. Now what we will do, we will find the concatenated string. Let's write it BAABCD, a dollar sign, DCBAAB. This is what we will do. Now what we will do here is that we will find the LPS array for this particular string. This dollar sign is basically given to us so that there is a difference between the string and the reverse string. There is basically a partition, and the whole string should not be considered as a single string because that will lead to a wrong answer. Okay? Now what we will do, because what we want basically that if there are some characters, let's say AB, and if they are also there, you can see they are also the prefix. They all are equal, means these characters are not required and they will be discarded from the string. That is why to find this particular thing, that how many characters, as if you just focus on the maximum number of characters to make it a palindrome or the normal number of characters, it will be just take a reverse string, just join them and they will become a palindrome. That will be obvious case, but to find the minimum number of characters, we have to find the LPS. Here it will be 0. Here also it will be 0. Here also it will be something 0. For this you can see this is 1 because B and B both are the same. Now for C again it will be 0. For D again it will be 0. Again here it will be 0. For this C it is 0. Now for this B again you can see there is a B and a B. Let's say this is a length, this is a I. Again it is 1. Similarly for the next case also you can see it is equal, so it will be 2. For the next case also it is equal, it is 3. For the next case also it is equal, it is 4. This is how we are finding that how this BAAB and BAAB are present, because that is what we want. Because in this original string there is a part which is already a palindrome, and that part you don't have to consider. We have to consider the rest of the part. You can see this part is already a palindrome, so we just want a D and C in the front. That can be calculated using this LPS array. There a prefix which is also a suffix in the reverse string. Now you just see that the size of this S is 6 and the last value is 4. So the answer is 2. 2 characters are needed. And you can see in the answer also D and C, 2 characters are needed to make it a palindrome. This is a technique which is used to find at how we can find the minimum number of characters to make it a palindrome. Now let's discuss the code part for this particular problem. So as I told you that we have to first find the LPS array, and the code for LPS array is what I have already explained to you all. So this is the code for the LPS array which I have already explained to you in the video. I have just taken the string and with the help of the string I have calculated the value of this LPS array with the same algorithm which we have discussed using a while loop, then checking with the different conditions, and here I am returning the LPS array. Now the thing is, for which string we have to find the LPS array. Just remember, we don't have to find the LPS array for the original string str. We have to find it using this particular string, which is the concatenation of s dollar and the reverse string. This is a very important thing. So first of all, what we will do, we will find the reverse string of this s. So we will take a string, let's say reverse, and then what we will do, we will just use the str reverse function to reverse this particular. Now what we will do is that we will take another string, let's say C, in which I will add str, then a dollar sign, and then the reverse string as we have discussed. Now corresponding to this particular string, this concatenated string, you have to find its LPS array. For that I will simply call this function which is compute LPS, and I will store that in a vector of int. Let's name is LPS only, and that will be counted for this particular string. Now, as I told you, the answer is basically the last value of this LPS string, which is subtracted from the size of the string s. So we have to simply return the size of this string str minus the last value, means the back of this LPS. For easy understanding, we can store it in a different variable also, just like this, and we can just return this answer. Let's compile this code. You can see that we have got the right answer for this particular sample test case. Now, let's talk about how we can submit it, and let's then check that if all the test cases have been passed or not. You can see all the test cases, all the particular test cases have been passed for this particular approach. Now, if we talk about the time complexity and space complexity for this particular approach, so the time complexity for this particular LPS array, to find this LPS array, as I told you, or if we talk about the naive approach, the brute force approach, it will give uh, it will give us O of n cube. But in this particular algorithm which we have taken to compute LPS array, it is just taking omega of n. It is just taking omega of n, because you can see that we are just having a iterator and it is just iterating to the complete string once. That is what we are just doing. So this particular function, which is compute LPS array, it will take omega of n. That is the time complexity for this particular function. And so this, and for here you can see that we are just using a string. Time complexity is omega of n, or maybe 2n, and space complexity is also omega of n. So this is how we can solve this particular problem. This is the time complexity and space complexity for this particular solution. Please like the video, subscribe to this amazing channel, share this video with your friends. Also comment down if you have any doubt or if this video is helpful for you. Thank you.